Good afternoon, everyone. Thank you very much for being with us today. After almost 70 sessions, welcoming 5,500 participants joining us from all over the world. We are honored to continue our second season today on the topic of the academic digital radar. Explore current technologies impacting tomorrow's banking. A little bit about fantastic speakers. Background, Mr. Paolo Brignardello is Chief Commercial Officer at Funds DLT, a cross-boundary decentralized platform making investment fund distribution easier, cheaper, and transparent. Mr. Olivier Debenis is the CEO of Lingua Custodia, startup specialized in the application of artificial intelligence to financial translations and develops customized machine translation engines. Mr. Eric Mully is IT Project Director at Société Générale, focusing on implementing new innovation initiatives to support the bank's transformation in an international context. Ms. Alessia Bonanno is Country Manager at BTO Research, in charge of planning, launching, and managing the expansion of BTO Research in Luxembourg. She will be joining by her team members, by the way. On the moderator side, we have my dear colleague Alex Poli, Head of Partnerships and Ecosystem Development at the LHoFT. Prior to joining LHoFT, Alex was a marketing teaching associate at the University of Quebec in Montreal and a serial entrepreneur creating companies in the space of e-commerce and alike. At LHoFT, Alex used to travel the world, connecting fintech entrepreneurs with the local ecosystem, and has been a master of ceremony interviewing thought leaders from all walks of life. Without further ado, ladies and gentlemen, Alex, the screens are yours.
Thank you so much, Anthony. Great introduction, as always, energetic. I love it. Hello, everybody. Welcome to this special edition on Industry Showcase. I'm very excited about today. And it's not just because we have a great lineup of speakers, but we're going to learn something quite unique today, something new that will be very useful for us who are in the financial and the technology industry. I'd rather to see into the future. It might sound like a science fiction, but our partners, BTO Research, have done it. So Alessia, the first time you introduced the idea to me, I thought you were talking about the new Star Wars movie that was coming along. But no. And you showed me, and it really blew me away what you guys wanted to achieve, and you've done it. So thank you so much for being with us today and sharing your experience, but also what your technology will do for the financial industry today with us. Alessia, the mic is yours. Please go ahead and unveil the secret.
Thank you, Alex, and thank you, Anthony. I will share my screen right now. You see my screen?
Yes.
Perfect. So thank you for this introduction, and I will start very briefly to give you an overview of BTO. So BTO is a research center and consulting company with the mission to bridge the gap between academia and business, and with the objective to accelerate digital reinvention. So we do this by being independent, by leveraging the knowledge that is produced within academia, transferring it to businesses to help them innovate. Our DNA is based on academic sources. So that's where we leverage the knowledge from, and the sources that we use for our applied research come from academia, as you will see today. And of course, we partner up with great universities in the United States and in Europe. We work on three main areas: inspiration to inspire change, research to define the best strategies and the best tools to innovate, and consulting to actually execute these innovation projects that we help define. We do this in various industries, as you can see, but today, of course, we're focusing on financial services. So I will leave the floor to my colleague, Marco Castelli.
So thank you, Alessia. Thank you, Alex. And once again, good morning to all of you. It's my pleasure to introduce you our research that we have named BTO Academic Radar, with the aims to target the top technology trends that are affecting not only financial services, but more in general, all industry, with in particular for this presentation, we have put a focus on the financial service market. So we decided as BTO to provide this independent and authoritative point of view, selecting and applying a methodology that starts from three of the best sources, in our opinion, with information regarding academic papers. So we selected IEEE, NCM, and Science Directs with the idea to applying SIME algorithm in order to extract these top trends based on the number of publications performed by professor and researcher in digital topics inside these kind of sources. I am a researcher and I know very well how it's difficult to publish on this kind of institutional report, because they choose only the top level academic papers. In the next slide, we have inserted our methodology. So very briefly, we started with the identification of a long list of technology trends. We defined it thanks to our expert that coming from academia and both from business. We also prepared a list of keywords with the semantic equivalence, because first, for example, as you know, IoT means Internet of Things. So when we use a keyword-based research, it's important to try to apply all the combination of terminology. We performed the first extraction of these results. And as we will see in the future slide, we created the global relevance of the topics. We selected the time frame January 2019 to February 2020 in order to have a good time span to analyze. And we have clustered this kind of technology on 4 macro clusters. The first one is user centricity, so technology like augmented and virtual reality that touch directly our customer. The cluster connected world that meets not only Internet of Things, but connected also different software and application. The global box of artificial intelligence with the different kind of we can say use case inside it, and the disruptive technology, more in general, technology like blockchain, 5G, 3D printing that are quite different between each other. We have also applied another filter in our algorithm in order to identify only papers that speaks about application in financial services. And in this slide, we can see the final output. Some of them are in common with the global relevance, for example, blockchain, augmented worlds, or natural language processing. But some of them are obviously very, very specific for financial services, like the topic of open API, strictly related to open banks, the world of open data, but also to some application of cybersecurity, for example, cognitive security for this specific field. For today's speech, we have selected 2 talks about 3 of these 10 technologies with an idea to provide you a snapshot of 3 different maturity of this technology. We started with near future, so technology that can be applied also today. We can see in the market several applications of that, and we have selected our number 1 ranking, that is natural language processing and speech recognition. Having a look on midterms, that means for us 3 to 5 years of application, we have technology like blockchain that, yes, we can see some application, but we think that in the next future, we will see also more use case and also more application of this technology. And having a long-term view, so from 5 to 7 years, we have selected quantum computing. That was the ranking number 10 in our report, that in our opinion, it's a very, very interesting technology. Actually, we are not able to see a near future application, but it's better for company to have a look on it in order to define also how to proceed with a long-term perspective. So I leave the floor to my colleague Alessandro Poli that will provide us a drill down on these 3 technologies. Thank you.
Okay, thank you, Marco, and good morning, everybody. So as anticipated, in the following slides, I will briefly introduce the 3 technologies mentioned by Marco, giving you some insights on the opportunities and risks that can derive from their adoption in the financial industry. Then I will present some key facts that allow us to understand the situation of the market with respect to those technologies. And at the end of my introduction of the technologies, we will have a presentation of real case studies from two fintechs from the LHoFT, Lingua Custodia and Funds DLT, and for the last technology, Societe Generale. Good, so let's start with the first technology, and natural language processing and speech recognition. These technologies basically allow machines to understand and act on the basis of content expressed in natural language, both written and spoken. Two basic use cases are in customer service or supporting employees in day-by-day activities. Let's talk about opportunities now in the financial sector. In banks, this technology can be used to help customers understand their contracts, explaining, for example, technical terms, etc. Other opportunities come from the extensive use of the data collected through speech recognition for business purposes, for example, understanding the habits of customers, their pain points related to a product or a service. And another opportunity is the acceleration that it can offer analyzing any kind of documentation, leading to higher efficiency in operational processes. While from the side of risks, we have to consider that in many cases, for some speech recognition implementations, we have to keep microphones permanently on. And this can have a lot of implications from the point of view of data privacy and cyber risk attacks. Another risk is that an unauthorized use of natural language processing and speech recognition while dealing with contracts or commands to be executed by a computer system, we can lead to signatures or product purchases without all the legal requirements. Or in some cases, we can have some user commands that are translated into mistaken transactions. In the next slide, we can see some key facts from the market perspective. First key fact, 75% of large banks are currently planning to deploy artificial intelligence-enabled solutions. And those solutions include natural language processing. So this is something that is already happening in the market. Second key fact, a 30% reduction of effort consumed by sales employees in banks has been measured in processes where natural language processing technologies have been introduced. And third key fact, the market is growing at a pace of around 16% in the last years. And in 2021, it is expected to be $16 billion big. Now let's briefly have some comments on the business value of those technologies. Overall, we can say that they have the potential of increasing customer satisfaction and retention. They can also help funds manager in understanding reports from the analysts and can also be used to automate the analysis of commercial agreements. Good. Now I would like to hand over to Olivier from Lingua Custodia that will provide us a real use case of natural languages processing. So please, Olivier, you can start with your presentation. Thank you.
Thank you very much. Hello, my name is Olivier. I'm the CEO and founder of Lingua Custodia, a company that applies machine learning to financial translations. Thank you. The idea is we are fully in the topic of NLP. The idea here is to show how we took one aspect of NLP and how we applied it to a specific pain point in the financial domain. So in a few words, Lingua Custodia was founded in 2011 and has been on the market since 2015. We belong to the fintech ecosystem. We are present in the LHoFT, and we also have two offices in France. Our clients are only financial institutions. Next, thank you. Why do financial institutions need to translate documents? They need to translate to understand what they invest in and to communicate to their clients. The way they do this traditionally is by using either translation agencies, they may have in-house translation teams, or because many people in the financial industry speak English on top of their native language, they may have to do it themselves when they don't have the time to externalize it. Next. This creates problems and challenges. It can be very slow. When you do everything manually, it can take 15 days to translate an annual report. It is very expensive. It ranges between 20, 30 sometimes. If you apply emergency rates, it can go above 40 cents per word. And also there is a problem of quality, which is not because translation agencies are bad in translating financial documents. It's just that financial translation is a financial expertise. And there are not that many freelance translators who have this capability. So therefore, there is a shortage. And this is where technology can come to make up for that shortage. Next. At Lingua Custodia, therefore, the idea is to propose a solution using NLP, which allows to speed up the process, reduce the cost, and bring quality by being more homogeneous in terms of translation. A good translation is very hard to define, but one way to define it is to translate always the same terms for one company in the same way. Next. So the solution that Lingua Custodia is proposing to its clients is to propose to develop ultra specialized machine translation engines. Microsoft Bing or Google Translate were mentioned before. In fact, it's as if we were creating dedicated Google Translate by document type. I will explain later why we do this. Those translation engines can be customized by client, because one of the reasons why one of the main topic of application of AI is language and machine translation is because it's a very complex problem, and typically each client is going to translate some aspects differently. We can customize those engines therefore for them. The solution is fully secure, there's no cloud involved, and is also, our platform is format friendly. Our clients just log in, put a PowerPoint, and they get a PowerPoint back immediately with a translated document, but also other documents. Next. So here you can see some typical use case for which we have developed specific machine translation engines, typically for annual reports where you need to follow the IFRS terminology. We have developed engines for equity research papers where it is very specific type of telegraphic style, which is again different from fund fact sheet or fund prospectuses. And there's always a different type. Our clients come to us either because they need to go quickly to translate documents, so that speed is a key element. They want to translate more, but at the same cost. So this is also when they come to us. And also when they want to make sure that in terms of quality, it will always be the same type of terminology. And we provide this solution that we develop ourselves in all the Western European languages, plus Chinese and Japanese. We also, so this is the techie aspect of the company, for the clients who can't proofread internally, this is a kind of auxiliary service we provide as well to find people who are specialized in finance who can check the output of a machine. And because we use the tech, we can reduce the price of this kind of finalized translation service. Next. So when it comes to natural language processing, we talked about this before. The use case I'm presenting here is about machine translation, but it can be used in many other type of domain, such as question answering, test summarization. Chatbot also relies on this type of approach and technology. At Lingua Custodia, so we are a team of 20-25 people. Half of them are on the technical side, and we have a lab next, which I'm going to introduce here. Because there are still, even if this is a very advanced application of NLP, there are still some challenges. It is very much used today, but there are still work to do. Typically, when you're going to a sentence, the machine translation will have a gender bias depending on how it's been trained. So this can influence also how it's going to translate some sentences. You have also some long-term dependencies issues. When you have something like my car is missing, it was stolen this morning. At the moment, the translation engines are working sentences by sentences. And it is hard for them to take into account previous sentences in a document. And ideally, what it should do is to take the full document into account. But the processing capabilities would make this very slow. So it's still not fully there. So typically, you can therefore have mistake in languages where you have like a il or elle in French, either it's feminine or masculine. You can have a mistake here, like you have in that example. If it was stolen, or what is it? Should it be in French the equivalent of she or he? And there it can make a mistake. Next. And the big challenge is also on terminology control. And this is where Lingua Custodia is working a lot. When you are in the financial industry, if you have a source text here in French, where you have a name of a company plus the name of a fund, and that the whole thing constitutes the name of a fund, and then you have a description, an objectif de gestion, and so on. If you put all this in a generic translation engine, which by definition has been trained with many types of text and documents in all areas, it won't know that the fund is a fund name, and therefore it's going to translate the name of a fund when it should stay the same in all languages. So therefore here it should stay as Sélection Dynamique PEA. And then also it won't know the specific acronym of the financial domain. Like it won't know that an FCP is a fund. And therefore this can make it unelegant to live in an English kind of text talking about FCP when people who are the readers won't have a clue what the FCP is. Also, it may give management objective instead of investment objective, again, because it has not been trained properly, or usually when it sees, it's not that it's been trained improperly, but it's been trained generally. So in general, in the same way, you know, if you just ask a translation engine to ask what to translate a hedge in a European language, it's going to think it's a hedge in the garden. It's not going to think it's a financial hedge, and the translation is different. Next. So we have some research work going on at Lingua Custodia, which rely on, which are on the topic of quality assessment. How do we properly assess the output of a translation engine? Comparing also the various neural machine translation models. I will not go into the detail of it, but this is one of the big topics. There are many different frameworks that do exist, and to which we contribute in the open community. Which one do we think is going to be the one for the next coming years? And also, this is so the type of work that our lab is publishing its output on in many conferences. Next. One of the big research projects relates to what I was mentioning before, in order to stop having to translate sentence by sentence. Because when a client puts a full document in the platform, the document is cut in sentences and then translated. The idea is that we translate the full document in one block. So that's one of the research topics. We do engage with the French National Center for Scientific Research, together with the funding also of the French army, because machine translation is also for each in Europe considered as a strategic topic of defense. The topic of working on terminology control is very challenging as well when you're in a neural network model, and also to make sure that there are new strategies for quality evaluation. And I think that would be all for me. So next for the last conclusion slide, but I think it's okay. And I will hand the floor back.
Okay.
Thank you.
Thank you, Olivier, also for talking about the challenges in this field. Now we can switch to the second technology. As Marco anticipated, we defined blockchain technologies in the mid-term category. This is from the point of view of a widespread adoption by the financial industry. However, we know that this is a real technology that is actually in place and in many cases also well tested. Good, I'm not going into too much details now. Basically, we can define blockchain as a distributed system where we store a chain of blocks containing transactions. Those transactions are validated thanks to a consensus mechanism that is distributed on all the nodes of the network. The main features are the immutability of the register, the transparency because all nodes can see and check the transactions, and security that is assured thanks to cryptographic techniques. The opportunities that can derive from the adoption of blockchain technologies in the financial industry are that the system will be resistant to error and attacks, since each node in the network keeps a copy of the database, and a single node that is getting offline does not affect the entire network. The technology is also ideal for keeping financial records, since the data is extremely difficult to remove or to modify without a consensus from the other nodes. There are still risks, however. We would like to highlight that there are some specific attacks to the network that allows to a party with a lot of computing power to take control of the system and consequently perform any modification on the transaction that were stored on it. Not to mention that many applications rely on public and private keys for managing the accounts where the money is stored. This is a risk in case a private key is lost, since this can cause that all the money in the account is no more available and it is consequently lost. In the next slide, we can see the key facts from the market perspective. So one, we have an estimation of the market size, which is expected to be 20 billion per year by the end of 2024. Two, the current biggest share of the market, around 60%, is accounted to the financial industry. So this means that even if there are many other applications in other industries, the financial sector is still the biggest investor in the technology. Fact three, if we consider the market capitalization of currencies and tokens available to the public, the amount of assets is valued more than $500 billion. So this is a big number, but not so big compared to the amount of assets that are globally managed. From the business perspective, what we can say is that in many cases, the adoption of blockchain technologies can lead to cost reductions, while at the same time offering some interesting properties such as transparency, minimization of risks, and an increase in productivity and efficiency. Good, so I would like now to hand over to Paolo from Funds DLT, who will present a real application of the blockchain technology in the fund sector. So please, Paolo, the stage is yours.
Okay, thank you. And thank you very much for asking me to join these presentations and to present Funds DLT and what we do. Myself, I'm Paolo. I'm responsible for the commercial activity in Funds DLT. And I want to start from giving more an understanding why there is a need of a new technology like blockchain within the fund industry. The fund industry is part of the financial industries and, of course, very important in Luxembourg. Here, I took some points that was raised by the paper from the LHoFT that is already been published several years ago, but it's still very much relevant to understand and the opportunities that are there. So first of all, it should be understood that even if the industry seems very booming these recent years, the funding industry, overall, only 10% of, roughly 10% of the, I would say, the European-wide population householder is buying funds. So it's a very relative small proportion that access these financial products that is very much important for many reasons, because anyway, they are for several reasons, these products are the most suitable product for many savings persons and householders. The challenge that paper was raising was, first of all, that there was a need to reach retail investors much more. Today, really, the retail investors, as in the statistics was demonstrating, do not really access that product. And this is the most important, above all, if you consider that these are very important for the long-term savings or even mid-term savings and the pension schemes. In other countries, or in the US, for instance, mutual funds are much more present into the pension and long-term savings than in Europe. Second point, very important, that the challenge that the industry has is really the accessibility of this product. So there is a real need to ease the process to access, easy access to these products, and above all for the new generation, like the millennials, that really have different habits today and a different way we will see later on. And third point, very important, is the compliance. Let's say in the way the industry and the way the products are distributed today sees, I would say, disintermediation, a strong disintermediation, and the jeopardization of the way the products are distributed or reach, I would say, the sales point and the end investors. And there is a loss of controls, I would say, in a sort of sense, in the way the products are sold. And there will be a need of much more great understanding and probably cooperation between the producer, that is called the asset manager as such, and the distribution side. And last but not least, there is also a digital competition out there, because there is a lot of, and we see that, a lot of transformation into the financial sector overall. New technology are coming, the way the, I would say, newcomers are entering into the space, the neobanks, as they call that, or that are really capturing a lot of retail clients with a very nice, much more nice experience into financial services, above all the cash side. Can you switch the next one? So looking back deeper into the problem, we see that today investors, and we talk about these investors that access, I would say, the financial product from, I would say, digital tools like apps, really wants much more personalized offerings. So something that speaks much more to them. They are very keen into sharing data. There's no problem for sharing data. They are used to do that with many other applications. But they want to have better integration also between, I would say, digital channel and also physical meetings with eventually talk with people, financial, but in a different way as it is today. For who is proposing service from digital perspective, they really have to restructure in the way they provide this service from, I would say, technology perspective. If you see, they have to develop a much more customer-centric business model, so that speaks much more to the investors, but also they have to simplify operating models, while I would say they need really to slash cost, reduce the cost, and create, I would say, the technology that are able to connect anything and anywhere. On the, I would say, the other side, the producer, the asset managers, they have a very much concern that they have no single view across different enterprise. So there are no visibility on what's happening when they sell, well, they cooperate with the distribution networks. They have a need also to transform the data, to collect much more data, to provide better service and better products. And above all, there is also this connection between systems still happening within the financial industry. Can you please change the slide? So looking into the fund distribution chain, today, the fund distribution chain, how the investment fund reach the investors is really much disintermediated. And so that's where Funds DLT brings the technology, the blockchain technology, because there is a need that all these intermediaries in the end speak to each other much better than today. So there is today, the organization today sees that every single layer into the distribution have its own stack, technology stacks. And most of the time they replicate the same activities, operational, I would say, back office activities, that and create, communicate between each other with files, with, I would say, even better connection by Swift, but nevertheless, always exchanging data, I would say, in not in real time. That's where a blockchain can bring value, because a blockchain is in the end a decentralized approach, decentralized infrastructures that connect and allows the intercommunication between different actors. Each actor will work its own infrastructures, but these infrastructures is able to communicate on real time with the other participant. And this, for instance, is a solution that is allows even this new technology connection. I would say having also relationship within the investor through apps, something that is really demanded from the new generation. The blockchain as such, as I was saying, has been said before, create a certainly efficiency, create a transparency, and of course, as I said, user experience. Can you please switch? So how we use blockchain in this case? So blockchain really create the opportunity to have an ecosystem that cooperate. And you see, for instance, that many parties interconnect through APIs. So we use open APIs standard as well. Can be connected to different existing systems, above all with the asset manager. We do not, funds DFT in our case, we do not use say crypto money at all. So we interconnect it again through APIs with the, I would say, the standard cash environment, so through banks. But inside the fund, the blockchain that we use, and we operate with the 3 smart contracts mainly. One smart contracts generate and manage the transaction as such, so registered transactions, and a second one at the how we call TL smart contracts issue shares, tokenized shares within the blockchain, and the first smart contracts that is connecting with cash receive the information from the cash environment, tokenize that information, and process the transactions against cash once the cash is there. That is called a typical transaction. The name is DVP, or deliveries versus payment, that ensure the security. I would say that both sides are executed. From one side, the cash is there, the shares are there, and then only at that time the transaction is done and the property is exchanged. All this process is on real time, something that today is not very much possible with the existing system. Can you please change?
Paolo, I'm sorry to jump in. I don't know if you almost finished. We are running a bit out of time. And
no, I can finish it very quickly. So what we see here is really that we see interoperation will create much more value, because it's really create a data sharing environment. You can switch on it. And just for information, we use Quorum as blockchain technology. This blockchain technology really have today the level of privacy that is requested by the financial industry. Have a great performance and allows, of course, I would say the governance of the data. We have achieved the transactions, performance of trading 600 transactions per second that represent 25 million transactions in 4 days. 20 million transactions represent the entire volumes of transactions in Luxembourg in 1 year. That's it for me.
Okay, thank you, Paolo, for sharing with us your solution, but also for giving us insights about the market. Now we can move to the last technology in our list, quantum computing. And as we anticipated, this technology is still in the early stages of maturity. Quantum computers are often referred to as supercomputers, since they have the capability to handle highly complex algorithms at very high speed. The main feature of supercomputers is that instead of working bits of 1 and zeros, they use so-called qubits or quantum bits. Eric will give you much details on this in the following presentation. The main outcome is that for some specific problems, the speed of calculation increases many times, allowing scenarios where with standard computers, it would be impossible to provide results in a reasonable amount of time. A big opportunity that we see in the financial industry is that if we combine quantum computing with artificial intelligence, we can potentially achieve very big results, since the training of the learning algorithms can be accelerated a lot, leading to very powerful artificial intelligence systems with all their applications and many use cases. Okay, let's now move to the perspective of risks. The availability of a lot of computing power, thanks to quantum computing, can potentially lead to problems on technologies like blockchain, which rely on the limitation of current computers in order to assure the integrity of transactions. Moreover, quantum computers pose a risk on data security, since they can have the capabilities of forcing current cryptographic algorithms, with a risk of violating the integrity and the confidentiality of data. Another risk is that probably general purpose quantum computers will never be realized. They will be dedicated only to some small specific problems. And this is a risk to be considered when taking decisions on making investment on this technology. Let's see now in the following slides some key facts from market perspective. As I was mentioning before, we are now at the end of the research phase, and we expect commercialization to start in the following 10 years from now on. This is also confirmed by our second key fact. We expect that by 2023, 20% of organizations will allocate budget on projects in quantum computing. This is a big acceleration from 2018, when a very small share of companies were investing in it. From the business perspective, we can again basically summarize that quantum computing could potentially allow fast computation for complex problems, for example, in pricing computation of assets or financial products. Moreover, in combination with artificial intelligence technologies, it can be a source of big competitive advantages. Now, I would like to hand over to Eric from Societe Generale, that will give us more details on the technologies and will share with us why they are the first movers on this disruptive technology and what are the potential that they see in it. So thanks a lot, Eric. Please, you can start with your presentation.
Yes, thank you very much for the invitation and to be able to share about this fantastic technology. And next slide, please. Just a definition about what is a quantum computer and what is quantum computing. We are speaking here about doing calculation on a subatomic level. It's really, really, really small. We are speaking about calculation on particles, on atoms. And this is also known as the second quantum revolution. The first was when we are building solar panels. This is all done because of the quantum properties. But here we are now speaking about manipulating subatomic levels and particle and atoms. Next. So to give an introduction, I will start about speaking about the hardware. Hardware, one of the known hardware is IBM, IBM one. This company provide a lot of and build a lot of quantum computers, real quantum computers. But what is such a device? We can say it's a big fridge, because inside this quantum computer, you are at something at 15 millikelvins, so it's more cold than the universe. So it's a real engineering problem to be able to construct, to build such a device. And as you can see, the CPU, the quantum CPU, is on the bottom of this computer, and there is needed to have a lot of fibers, coppers to connect this CPU to the outside world. Next. And the outside world, to manipulate and to program this computer, you see the CPU at the right of the screen. You need a lot of additional components which are wave generators, fibers, and so on, to be able to communicate with the quantum CPU. Next. But what makes the difference between traditional and quantum as the major element is the famous qubit, the qubit compute, the quantum byte, the quantum bit, where it can have multiple values in the same time. It can be 0 and 1 at the same time. And here we have the full potential and the power of a quantum computer. And we have two major properties, quantum and quantum properties, which are superposition, and this is the fact that the qubit can be in two different states at the same time, and entanglement. Entanglement is the fact that you are connecting, linking two qubits or more, even more, together in a way that when you are doing an action on one, you have an immediate reaction on the other qubit, which are in this specific state. And this gives the power of the computer, the quantum computer, because with only 300 qubits, you can have the possibility to encode more different states than atom in the universe, in the known universe. So it's quite huge, only 300 qubits. But as all technology, we have two major constraints. The first one is the no copy theory. As the qubit can be in multiple states at the same time, you cannot copy the state, because you don't know what is the state of the qubit, so you cannot copy it. And the second one is the measurement. Measurement, when you want to know what is the state of the qubit, you have the quantum state of the system collapsed, and you can only have classical outcomes. Next. Today, we are in early stage. So the technology to build the qubits is not finalized. There are a lot of different technology. You can have superconducting loops like what is used by IBM or Rigetti or some other company. You can have lasers, microwaves, topological with fermions, Majorana fermions. All these are technology with cons and pros. So you have the problem of scalability, how to build a quantum computer with 10, 100 millions of qubits is really difficult, and it's not done for now. But based on the technology, it can be more or less evident. And next slide. With the different physical technology, you have also two major kind of quantum computers. The first one is a universal computer, circuit model, based on what is doing IBM, Google, or Intel. And here you can program the computer to solve any kind of problems. And you have another one is the adiabatic model or specialized analogic model, which is a specific model of computer who can only solve one kind of problem. The problem is the minimum of energy. So, for example, the traveler problem to be able to travel city by city in the best way and only one. So this is a kind of problem. This model of computer, quantum computer can say. And here you have some companies like D-Wave, a Canadian company, or simulators. I can speak about this later. For now, the model, the universal model, you have only computers with less than 100 qubits possible. So this we are in a phase where we are speaking about NISQ, noisy intermediate scale quantum computers. It's meaning that these computers are too small to have the ability to solve business problems, but it is possible to make some algorithm who can take advantage of this computer. Next slide. So the quantum volume and the exponential growth of the capacity and the power of the quantum hardware. As you can see, we are really in an exponential curve to see that since the beginning of this theory based by a famous scientific, it's Richard Feynman, you see that the power is increasing and year by year. And for this, IBM, one more time, has committed to be able to build a computer, a quantum computer with 1,000 qubits in 2023. So here we can say that it's a real milestone to be able to go from what is known as the NISQ area to a real business-ready quantum computer. Next.
Sorry to jump in, Eric, as we are really
okay.
out of time.
I know it's very passionate.
Quick question, and because it sounds fascinating, real science fiction, Star Wars, as I mentioned at the beginning. Just quick question to you, so maybe we can wrap up. Why is Société Générale interested in that? Are you going to make money on that, beat the market? What's the goal? What's your vision?
The fact is that this is really disruptive, and the way is to as I said, to be able to make a better service for the client, and to at the end to make money because of the speed of such computer. And we see two major possibilities. The first is about calculation, like pricing, and the other is also about risk. It's meaning that with such a power, it is possible to have some algorithm to minimize the risk we have to take and to be able to take on some financial product. And these are really two major positions where we are looking about the speed of the quantum computer.
Fascinating. Maybe you want to wrap up your. Do you want to add something on your presentation, Eric?
Yeah, perhaps a takeaway, a global takeaway about the technology, as we say that it's not for tomorrow. It's more far away, but it's very important to look in the technology because it's really disruptive. We cannot, we have to rethink all the way we are doing the algorithm, the way we are doing the calculation. And the second part, which is not linked to the computer itself, is about the risk, about security. And here also the fact that the cryptography has been proven to be in risk. We have to take care about what will be the world, post-quantum world, where such a device will be able to crack some cryptography algorithm.
I mean, that could be the perfect tool for cyber warfare.
Yeah.
Of course. But then funds DLT could do hundreds of millions of transactions per second. So Paolo will be happy.
Yes, sure.
Thank you so much. Let's maybe, yeah, it's intriguing session. So maybe let's jump on before we wrap up everything on some of the questions we have from the public listening. So one question from Dan. Anthony, I don't know if you can give the mic to Dan quickly.
I think he has just left. Dan, are you there?
Oh, he just left. Okay, he found the session very intriguing, and I think it's the same for most of us. Then maybe I will jump in one question. It's going to be quite practical because, I mean, you guys, the BTO team, you are the bridge between academia and the business, okay? Mm-hmm. And the whole purpose of the radar is look at what academia is doing to say, okay, that will happen. And my question is to you, why academia is so important today? I work in academia, and when I was working as a professor, I thought that the business is disconnected what's going on in the world. Now that I'm in the business, I think that academia is disconnecting to what's going on in the world. So how do you guys can do this bridge? I don't know who wants to answer. Alessia, Marco, or Alessandro?
If you want, Alex, I'm happy to answer to you, to give my point of view, obviously, because as you know, in my previous life, I was a researcher from also the academic part. So in my opinion, academia gives us a very independent point of view on what's happened in, or sorry, not what's happened, what can happen in the market, because they are not actually following any specific market trends, because they have not to sell anything to us. So the academic researcher can focus on technologies that can bring real value to people or to the organization. So in my opinion, have a look on that. You have the opportunity to have a look on the future outlook of a product portfolio of company that will develop the industrial application on it.
Thank you. Interesting. I don't know, Alessia or Alessandro, do you want to add something? Alessia, go ahead.
Yes, I think that's what Marco was saying is the basic point, also why BTO is basing most of our researches on academic sources. But at the same time, what we do in BTO is using those sources and connecting them with the business. So when I said that we're bridging the gap between academia and business is exactly what you were talking about. So yes, there might be the feeling that these two worlds are disconnected, but there is value in academia. And it's a pity for companies not to leverage that value. So that's what we try to do as BTO. We try to fill this void and make those that knowledge and the applications that are looked in by academia applicable to the businesses. So we're there for that, to bridge that gap.
Yeah, fascinating. But if I may also add another question is on your radar, it's amazing because I can see beforehand what's coming, because the academia, the smart guys are working on it. But how do you assess on the, not say the adoption, but yeah, maybe the adoption by the industry of those technologies? How can you say that in maybe 15 years, quantum computing will be adopted? How can you do? Because I mean, on the NLP AI, I still don't understand the thing. So smart guys like Olivier, they're already in it. But who knows how much time it will take for blockchain, as Paolo mentioned, that we are quite still early stage, even if the technology is existing. Quantum computing, again, quite science fiction for me. How can you assess that the adoption of the technology will be? Or it's more by, I don't know, discussion with the industry itself? Alessandro, maybe you want to take that one.
Well, yes, in many cases, the tool by itself is not able to give a timeline for the adoption of the technology. So in many cases, you still have to have a confrontation with the market. And this is what we are trying to do now. So we are trying to compare the results of our academic radar with the actual performances of the market in the past, so that in the future we will use this tool also to give some kind of predictions on what the things are going on. But this is still under investigation from our side.
So can you tell us already that I don't know, robots, AI will replace us, do poetry in the next years, or even maybe be our boss? That you cannot do yet.
Not yet. We cannot predict it at this moment.
Do you have an idea on the question, Olivier? You who's working in the field?
Yeah, I don't think it will happen. All the AI models rely on data, and you need to collect even for what could appear as a simple thing, translation. You need to collect a huge amount of data and to clean it properly and to have it properly selected to do something, just to reach the point of translating one text into another one. There was a question on speech recognition. Speech recognition is even more complicated because then you have the accent that comes into the picture as well, plus the surrounding noise. So that brings even more data you need to capture on this to have something that works. So imagining a world where, you know, a robot will be your boss, Alex, that means that he will have needed to capture all the potential set of data. And I don't know how it's possible on how you as a human being, you would react to any type of action that it would be done, you see. And that's, you know, the issue is on the data aspect and not on the technology behind and the calculation power. It's more on the collection of data.
Eric, what's your insight? I mean, quantum computing, they will need to access those data.
Yeah, I think that if we speak about quantum computing, it's really nobody can say that we will be able to build something which can be usable at the end for the business. But never know. Who was able to think 40 years from today how many transistors you can put in 1 centimeter square room? Yeah. So I have it's the first time I think we are in this kind of disruption. Because it's always new the way you are. You have to think about the problems, the way to build, the way to communicate with such a device. It's totally different. So it is very important to people to understand that. For me, it will come. I have no doubt with this. It will come, even if it's difficult to imagine when and how, but it will come. Okay. And so it's better to be prepared on this than to let the train go faster and faster, and at the end it's difficult to go on.
But I still don't have to prepare my CV for my next.
No. This you are sure.
I'm safe for a few years. That's good.
Yeah.
Those are the good news of this webinar. We are safe for a few years. Thank you so much. I don't know, Alessia, if you want to add something.
Well, I wanted to thank you for the opportunity today. As you said, I thought about this session early this year. It took us a while to actually put it together, but I think there is a lot of value in what we developed in BTO, and I think that what the industry is asking itself today is where are we going and what's happening next. So the radar is there to give a perspective and give an answer to this question. Of course, you know, we do the math, we do our job, but what the future holds is still yet to come. So we're there to try to apply research and knowledge that comes from universities to actually give a valuable answer and help the industry.
And to finish on what you said, what the future holds is also up to us. And I would like to thank you all for your great work, and also to our entrepreneurs, because you are defining the future. So thank you again for your